Now I'm in 90th question, PSNIT Foundation, Level 3 Kinematics. The question I'm reading out, I'll put this in the description box also. The question is, there are two stones A and B, that are dropped from top of two different towers such that they travel a distance of 44.1 meters and 63.7 meters in the last second of their motion respectively. With this information, we have to find the heights of the two towers from where the stones are dropped. So the given information, I have kept it on the board. This is about stone A. Stone A traveled this much meters in the last second of its motion, and stone B traveled this many meters in its last second of its motion. We are going to use the formula distance traveled by the body in the nth second, which is u plus a by 2, but this is a vertical motion, so I am writing it as g by 2 times twice n minus 1. So the same thing I'll apply in this case also. So distance traveled by the body in the nth second is u plus g by 2 times twice n minus 1. Distance traveled by the body in the nth second is given to us 44.1 meter. Since the bodies are dropped, so this turns 0. In this case also, initial velocity turns 0. G is a 10, so let's take this as 10 or 9.8, both of them will do. Then we have 9.8 by 2, which is 4.9 times 2n minus 1. This n we are supposed to find. So 44.1 by 4.9 is a 2n minus 1. Decimal at the same location, so we can avoid it. 49 nines is 49 nines is 441. Transposing this, we will get 2n is a 10 and n is a 5. So the first stone's last second is that 5 seconds. Let's talk about the second stone. Distance traveled in the nth second is 63.7. This is 0 since the object is dropped. And g, if we take it as 9.8, our calculation becomes easier. So this is 4.9. 9.8 by 2 is 4.9, and here some 2n. I can write 2n1 like I can do this, minus 1. So then this is 63.7 by 4. So 49, 13 table is 63.7. Then transposing 1, we get 2n1 is 14, and finally n1 is 14 by 2, 7. So 7 seconds. Since we know by second equation of motion, S is ut plus a half gt square. And if this is considered as a height from which these stones were dropped, then since the stone is dropped, this turns 0, and this part is a constant. So we will get height through which the stones are dropped is in a way proportional to the square of time taken in the nth second, or time duration. Something of this kind. Now, according to the question, we are supposed to find the ratio of heights through which the stone A and stone B are dropped. So, height through which these are dropped is proportional to the ratio of time taken by stone A to time taken by stone B. So, in that case, this can be written as time taken by stone A, and this one can be written as a time taken by stone B. In that case, this is a 5 square and this one is 7 square. So ratio of heights through which the stones are dropped, or ratio of heights of the towers from where the stones are dropped, is 25 by 49. So this is the answer.